Been doing pretty good going from scientific notation to standard notation, or standard notation to scientific notation. So we got to add a little bit to this today. We're going to add and subtract with scientific notation. All right, so the first part of this is probably the easy part, or hopefully the easy part. If the two numbers have the same power of 10, so that means the same exponent, you just add or subtract with the front number. All right, so in this case, you can see we got the same exponents. We got a -5 and a -5. So what that means is I can add my front numbers, the 1.9 and the 5.42. When you add or subtract with decimals, you got to line up the decimal points. So I got 1.9 plus 5.42. There's that, straight down. Anything that's empty like that, you can fill in zeros. So we got 2, we got 3, carry a 1, that makes 7. Decimal comes straight down. All right. So this was in front numbers. Once I do that, the answer is going to be the decimal I got when I added times 10 to whatever the exponent was to start with. All right, so those are the easy ones. If the exponents are the same, you add or subtract with the decimal part, and then add times 10 to the whatever back to it. Any questions on that? Not horrible, right? It'll get a little tougher, but try those two. Pay attention with the signs because we got a addition problem and a subtraction problem up there. One left. Marcos, what you got? Yeah, so we got 8.5 times power. Exponents are the same. 6.2 plus 2.3 gives me that 8.5. Corey, on the right here. Yeah, we got 5 times 10 to the -3rd power. 9 minus 4. Because like I said, it's a subtraction problem. You got to pay attention to what kind of math we're doing. 9 minus 4 is 5. Keep the 10 to the -3. So we got 5 times 10 to the -3. Any questions on those? All right, so those are the easy ones. If the exponents are the same, that's what we do. So obviously, we got to do something that they're different, right? Because they won't always be the same. So before we get to the ones that are different, we got one like this. All right, so Natasha needs to find the sum of those two numbers. You got two options. Option 1, you can make them both scientific notation and see what you got. So I've got 8.65 times 10 to the 4th power, and I got 43,000. How do I write 43,000 as scientific notation? 4.3 times 10 to the 4th power. So look, my exponent, whoops, I forgot the 10. My exponents are the same then, right? So now I could do 12.95 times 10 to the 4th power. There is a problem with that. I'm going to come back to that, okay? Anybody tell me what the problem is, though, first? What's the problem with my scientific notation?
They're all up. Should it be like negative three? Is the decimal in the wrong?
The one, you put 12 points.
I got a 12. And 8 plus 4 is 12. So that's how we got that. That's the problem. We're going to go back to that in a second. I'm going to show you the other way first, though. So for the other way, 3,000. Right? What's that scientific notation in standard form? How many zeros should I have on there? 2. I got 2 digits already after the decimal, so I need 2 zeros. Then I got my 5, my 6, and my 8, so that's 86,500. Okay? If I add those, I got 0, 0, 5, 9, 12. Where's my decimal go? To put it back in scientific notation. After the 1, between the 1 and the 2, right? So we'd have 1.295 times 10 to the what? What would my exponent be right here? 5. Everybody follow how we got that on the right? We changed them to standard notation, added them, and then changed them back. So the one on the left had a problem. We said it has that double-digit number, and we need a number between 1 and 10, or 1 or higher and less than 10. So basically 1 or 9, 1 to 9 for that first thing. All right, so that means I need to change my decimal. If I change my decimal, I'm adding another number to the right, aren't I? So if I add another number to the right, I have to add 1 to my exponent. Does that make sense? It shouldn't happen this way, but just as an example then, let's say we had 123 times 10 to the 3rd power. All right, so if that's the number we got, where would the decimal have to go? Between the 1 and the 2. So how many digits did I add to the right side? 2. So my exponent would have to become a 5, 2 higher. We see how that's going? For these problems, you won't have to add like 2 digits like that, but we'll get to stuff where you might have to.
So which way did you recommend do it the most?
If the exponents are the same, it's probably easier just to do the math like on the left here. All right? If the exponents are different, that's where you get to the ones on the right. All right, so like we said, we got different exponents, right? When you have different exponents, what you're going to want to do is change them to standard notation. So I've got a -3 on this first term. That means we need 3 digits in between the decimals. How many zeros I got to add? 2. So we got 0.007. All right, everybody good there? Same idea here. It's a negative exponent. Decimal goes to the left. How many zeros will I have to add? 3 zeros, because I need 4 digits in between. So I'd add 1, 2, 3. So when you add or subtract, you got to line up your decimal point. So when I line up the decimal point and put in those 3 zeros, the 6, the 8, that is what I would have. Everybody kind of follow? So I changed them to standard notation. I'm going to fill in a 0 just so everything's got a place value. I kind of covered it up, but this was a subtraction problem. I got 0 minus 8. I got to borrow. That makes it 10. So 10 minus 8 is 2. I got 1 minus 6. So again, we got 11. 11 minus 6 is 5. 6 minus 0 is 6. 0. Decimal goes straight down. Okay? So to go back to scientific notation then, where's my decimal go on this number? Between the 6 and the 5, we need a single digit number. So I have 6.52 times 10. How many digits I got in between? 3. 2 zeros and a 6. Since it's a decimal, that's a negative 3. Not always, but a lot of the time, it's going to have the exponent of the higher number. Negative 3 is higher on a number line than negative 4. Okay? So it's usually going to have the exponent of the higher number. Any questions on that? So just kind of got some extra steps to it, right? You got to change them to standard notation. You got to do the math. Then you got to change them back. Not exactly the hardest thing to do, not exactly the easiest, because there's a lot of chances to make mistakes. And then make sure you line up decimals, or if they're big numbers, you got to start at the right side and have everything lined up, like the ones, the tens, the hundreds. All right, so try these two. So I would say you change them to standard notation, do the math, change them back. There is another way we can do this, but I think this is the simplest to understand. All right, so one on the left here. Nick? Yeah, we got 5.04 times 10 to the 7th. So we add. Everybody good with turning them into standard notation? So when we add in all those zeros, have the zeros there because that's going to help us with our exponent, right? 0 plus 4, 7 plus 3 is 10, carry the 1, 1 and 4 makes 5. Where does the decimal go? Between the 5 and the 0. All right, so when we write our scientific notation, zeros that are at either end, either the far right side for the decimals or the left side, wait, I did that backwards, sorry. Far left side for the decimals or the right side for the big numbers, we cut those off. Any zeros that are in between non-zero digits, we got to keep. So we're still at 5.04. Everybody go to that part? Got to keep that 0 there. Times 10. How many digits we got? 7. I got 5 zeros, 4, and that other 0. As I said before, most of the time, we're going to have the exponent of that higher one, okay? There's a couple exceptions sometimes, but for the most part, you end up with that higher exponent. All right, so this one here on the right. I got 9. I'm going to have 5 zeros. We got 8. How many? 4. When we have our zeros, we want to line them up from the right. And then I got my 8. So when I'm subtracting here, that's what I'm subtracting. 900,000 minus 80,000. So we got zeros right there. We got bottom. So that becomes an 8. That becomes a 10. 10 minus 8 is 2. 8 minus a 0. So we got that. Where's my decimal go? Between the 8 and the 2. So we got 8.2 times 10. 5. Again, we end up with that same one as the big one, right? Any questions on either of those? This is a little bit more complicated than what we've been doing, right? You got to change it to one thing, do the math, change it back. I'm going to show you the other way, but like I said, I think this way is a little bit easier. The other way, and I'll just use this one here on the left. We'll keep our answer there. So that was a 7. The other way we do this, we got to make the exponents match. The exponents tell me how many digits are to the right of the decimal since they're positive ones, right? So I would have 6 digits to the right for this one. I got 7 digits to the right for that one. So to make them match, I'm going to take my decimal and move it over. So now I would have 47 times 10 to the 6th power. Everybody follow what I did? I made it so there's one less digit to the right. That means I knocked down my exponent 1. And then we still have the 3.4 times 10 to the 6th. So now we add 47 plus 3.4. 47 plus 3 is 50 plus the 0.4. So I'd have 50.4 times 10 to the 6th power. To get my decimal back right, I have to move it over to the left and add another digit to the right. When I add another digit to the right, exponent goes back up. That's how we get times 10 to the 7th. To me, that first way, change them to standard notation, do the math, change them back is going to be easier. A little more likely to get confused on these, especially when we have the negative exponents, okay? All right, y'all do this one. Ethan, what you got?
9.8
Times 10 to the 5th power. All right, so one option, make them both scientific notation. So we'd have 6.4 times 10 to the 5th plus 3.2. And when we do that, I got 5 digits to the right, so that's times 10 to the 5th. That means the exponent's the same. 6.4 plus 3.2 is 9.6. Keep my exponent. So that's one way. Other way, 1,000. When I change that, I got a 6, a 4. I'm going to need 4 more digits after that decimal. So I'm going to add on 4 zeros. So that's 640,000. I would want to write those vertically to add them, to have them line up. But when you add those, you would have 960,000. Decimal goes there, 5 digits after. So it's 9.6 times 10 to the 5th, either way. Any questions? All right, so now we got to subtract. I'm going to go ahead and do this one, okay? So just pay attention, follow along. If you got a negative exponent, my decimal's moving to the left, how many digits do I have to put in between, or how many zeros I got to add to get the 4 in between? 3. I got to add 3 zeros. Look, we got 3 zeros right here, right? So that means they're going to line up the same. So I got 0, 0, 0, 5, 4, minus, still going to have 3 zeros, right? So when we subtract, that's a 2, that's a 2, zeros, decimal comes down. Decimal will go here, so I got 2.2 times 10. How many digits in between? 4. 3 zeros and the 2. That's 4 total. So that makes it a negative 4 for my exponent. I could change them both to scientific notation to start with, and they'd be the same, but you can't always tell that for sure by just like looking at it easily. So sometimes going the standard notation is going to be the easier. Everything in between the decimals is what we count for the exponent. So we got that 2 and the 3 zeros in between our two decimals.
Oh,